Okay, so we're going to be having a look at the 2020 HSC Advanced Maths paper. We're going to be looking at questions 6 through 10 in the multiple choice. Some of these questions are a little bit unusual, and so they can be a little bit difficult. They're not overly hard compared to the questions in the paper. Some of them are just a little bit odd. So we'll start with question 6. So question 6, we have what interval gives the range of the function? Well, we can just draw this function. So this is y equals cosine of 3x shifted up by 5 with an amplitude of 2. So if we draw our xy plane, it's shifted up by 5, meaning it's centered at 5. It is cosine of 3x, which means the cosine function repeats 3 times within the 0 to 2 pi interval. And it has an amplitude of 2, meaning it goes up to 7 and down to 3. So we can just draw this. Looks something like this. We can see immediately that the range, which is the collection of possible y values, so the outputs, is going to be from 3 to 7. So the range will be from 3 to 7. So this is going to be B. Now, question 7, we have a diagram, shows the graph, which is made up of line segments. This is sometimes called a piecewise defined function. So we are required to find the integral. Now the integral is just the area between the function and the x-axis, with the caveat that any area created between a function and the x-axis which is below the x-axis counts as negative. So we just need to calculate this area. Many students get fooled by these kind of questions. They tend to think that this actually involves integrations, which it does not. This is just looking at areas. So we have a line here, we have a semicircle here, then we have a line down here. This is 12, this is 10, this is 8. So immediately we're looking for all of this, but the bit below the axis is negative. So first we can see that these two triangles must have equal area. The one below the axis will be negative, the one above will be positive. So these cancel out straight away. Now we are left with a rectangle and a semicircle. Rectangle is 3 units high and 8 units long, so its area is therefore 24 units squared. The semicircle goes from 4 to 8, so the radius must be half of that distance. So the radius here is 2. The area of a full circle would be 4 pi. Of a semicircle it's half, so this area is 2 pi. This means that the integral from 0 to 12 of the function of x with respect to x is in fact equal to the area of the rectangle, 24, plus 2 pi. And this is answer A. Now if we have a look at question 8. Question 8 is a slightly unusual question, and we're going to be looking at the curvature of the graph in order to work out what the actual answer is. You sort of have to assume certain things about the graph in order to get this. So when we look at this function, we have, it's sort of like a parabola on the side. We don't know that it's a parabola on the side. Probably is, or a logarithm or something like that. We're not sure what it is, but it sort of looks like this. And this has an x value of 1. So immediately we can see the function when evaluated at 1, f of 1, is positive. So we know f of 1 is greater than 0. If we look at the slope of the tangent at this point, something like this, the slope of this tangent is definitely positive. So f prime of 1 is definitely greater than 0, but it looks slightly flatter than a diagonal. And so this means that it is likely to be less than 1. So this is likely less than 1. Or could be equal to 1, but it's reasonably close. If we look at what's happening to the gradients, here before x is 1 it's quite steep, over here after x is 1 it's reasonably flat. That means the gradient is decreasing, so this means that the second derivative at 1 must be negative. Now, whatever the function is from the graph f of 1, this is bigger than 1, assuming the graph is to scale. So we have several pieces of information here. We have the second derivative is negative. We have f of 1 is greater than 1. We have f prime of 1 is greater than 0, but likely less than 1. From all of this, we can infer that f double prime of 1 is less than 0, which is less than f prime of 1, and that is less than f of 1. So this is the likely answer, and this is A. If the graph is not to scale, the answer could be slightly different here, but A is definitely the answer to this particular question. So now we're going to have a look at question 9. So in question 9 we're told about melons. I suppose the weight of melons is normally distributed. They tell us with a mean and a standard deviation. A melon has a weight below the lower quartile, but not in the bottom 10%. So if we draw our normal distribution, something like this, there are known percentages in certain standard deviation movements from the mean. So if we're moving down one standard deviation and up one standard deviation, these each have 34% of scores. If we're moving down another standard deviation, this has 13.5% of scores. If we're moving up one standard deviation, this has 13.5% of scores, and so on. So we're told above the bottom 10%, so down here we have about 2.5%, up here we have about 2.5%. So 10%, the 10th percentile is about here. But we're told below the lower quartile, well that's the 25th percentile, and that's about here, given that the peak in this case is the median. So we're going to have a range that looks something like this. Then we're just trying to identify from the possible regions that we've been given which one is the correct one. Well, it's definitely C. C is our answer. Now we're going to have a look at question 10. This is a very weird question. These kind of questions tend to catch students. They get stuck on them and they're not really sure what to do. But it is doable in a number of different ways. The method I'm going to use here involves derivatives, but there are some other methods where people discuss, say for example, intuition of understanding the functions. It is possible to do it that way. I'm going to use derivatives here. So we're given some functions. We're not told what they are, but we know roughly what they look like. We are told some new function h of x is the function f of g of x. So g is nested inside of f. And we're asked how many stationary points does h of x have if x is between 1 and 5. So stationary points occur when the first derivative is 0. So we can calculate h prime of x. This is going to be g prime of x times f prime of g of x. This is just the this is one of the forms of the definition of the chain rule, right? So this looks sort of complicated, but you've definitely seen this at some point in the course. This is just chain rule. If we're looking for stat points, this needs to be equal to 0. So this is our condition. Now this only happens two ways. 1, g prime of x has to be equal to 0, or 2, f prime of g of x has to be equal to 0. So g prime of x equals 0 means that the slope of the tangent of g of x is 0. So if we look at the function g of x, it's a sort of like a parabola. Its slope is 0 at one point. This happens when x is equal to 3. So that means h prime of x becomes 0 when x is 3. So this is one stationary point. And that's the only stationary point for the g prime of x equaling 0. A second possible solution comes from f prime of g of x being equal to 0. Now, what we are trying to find out, we're looking at f prime of x. So this is the sort of bell curve looking function. And then we're evaluating it at g of x. So we have to ask ourselves, when does y equals f of x have a flat tangent? When is the slope of the tangent of y equals f of x equal to 0? Well, it's equal to 0 at around about x equals 1 or something like that. That's the sort of peak of the bell curve here. So what we need is we need f prime where g of x is equal to roughly 1 in order to give us f prime of g of x is equal to 0. Now g of x, of course, is the big parabolic function. That becomes a number close to or just slightly less than 1 on two occasions. It happens when x is about 1.5. So if you think about the graph of this, we're asking ourselves, when does y equals g of x have a y value equal to a number just slightly less than 1? Well, if we draw this, if this is 1, it has a number slightly less than 1 here and here. So that's roughly at about x is 1.5, and the other one will occur roughly at about x is 4.5. Could be a little off either way. It could be, 1.4, 1.6, or 4.4, 4.5, etc. But there are definitely two values here that make this function a number slightly less than 1. And that means there are two separate values which will make f prime of g of x equal to 0. And those two values are going to be x approximately equal to 1.5 and x approximately equal to 4.5. They're likely values close to these. We're just going to say approximately. We don't need to know what they are. But the fact that there's 3 of these, they all fall between 1 and 5, tells us that there must be 3 stationary points in the function h of x, so therefore the answer is D. Now you can try and do this question without the derivatives, just trying to think intuitively about what happens when you nest functions in other functions. That can be a little bit complicated. So using the definition of the chain rule derivative here was quite a simple way to go about it.